My name is Britt Johnston. I'm the group manager for the SQL Server Appliances team. My team builds a family of appliances, and we'll cover some of that in the discussion today. Right, Mark? We'll go through that? Am I going to do that? Okay. They're going to tell me what to do. So we'll walk through some of that for you, give you a high-level view. But what we're really here today to talk to you about is the private cloud appliance, what we call, or what's on the show floor in what we call the server aquarium, the HP database consolidation appliance. And that's an appliance that's specifically designed for high I/O demand workloads. And so we'll go into some of the details on that. How many people here have been to the server aquarium and seen that particular appliance? So a few hands. So for any of you who haven't done that, make sure you come by. One of us will be there, and we'll give you a tour, let you take a look at the real thing. And so that's, I think, really highlight for us to be able to not be quite as abstract about that. And I'll save you my pitch. I'll give you that there. So let's talk about at the starting point, kind of why we got into this. One of the things that we've heard over time is the real challenge in delivering scale-out solutions for significant workloads, and especially across different IT infrastructures. And so solutions that provide real efficiency, have good cost to value characteristics, have aggressive time to solution, are able to scale and design to scale in reasonable increments, and really allow the variety of deployment possibilities that you guys have in the real world, where you have specific requirements for on-premise deployment specifically in this case. Now, if we break that down into the way we think about this, this concept of hybrid IT is a useful one to talk about. We really see that applications or solutions, I guess, at the level that you deliver in the real world are really built up out of components that need to run in multiple environments, from traditionalized systems that are maybe your most demanding mission critical on the metal type systems, to really the trend now to create not only infrastructures on premise but deliver them as clouds, and we'll get into our definition of what we think of that, to also even extending out into use the various public clouds that are out there. So building solutions that can span that spectrum is one of the areas that our team is focused on helping deliver. Now, in terms of where we see people focusing in these different areas, if we look at in the traditional space, some of the very demanding workloads around large OLTP, where you've got maybe either extreme performance or extreme reliability of both requirements in there. Data warehousing, where you have massive data warehouses in the hundreds of terabytes kind of range. And up and coming, really, the whole big data world, where there's massive digitally born data sets that need to be constantly looked at using some of the newer data exploration technologies. Those are things that tend to run on the metal in a more traditional approach. And often there are extreme needs around both mission critical and compliance around those. Often there's specific laws that need to be followed in terms of those systems, and so they fit that particular space. The next one is around private cloud, where we also see OLTP workloads, although they tend to not be quite as demanding from a workload or from a size or complexity perspective. We also see lots of BI workloads, smaller data warehouse workloads, and of course as data marts, and then of course lots of mixed workloads or hybrid workloads that need to fit into there. And often they have similar characteristics around compliance. In some cases, that drives them to be on-premise, so they have to be located in particularly specific physical locations, and so are driven around that. But the private cloud comes in when you really want to take advantage of the economics that provides. And we'll get into some of the benefits of that a little later. Now, when we get into the public cloud, which is really a new space for a lot of us, we start to see other demands, really trying to take advantage of elasticity, trying to take advantage of general infrastructures or shared infrastructures where there's either highly variable amounts of work that need to get done, and you can offload that into an infrastructure that you don't necessarily have to maintain or create yourself. Now, from a database perspective, we've tried to build out a set of solutions that cross all these boundaries, and in particular, SQL Server 2012 and SQL Azure provide access to these across the entire spectrum. And we've tried to make sure that we have a set of common resources that we can tap into across those for your security, for your management, and for your development. So providing some consistency across all those is something that we understand is important, and we strive to do that. So why appliances? If I think back 4.5 years or so now, for me, I really kind of understood this best, I guess, when I was visiting customers and asking them what they needed from us in terms of a product. And at that time, they weren't actually asking for appliances. It was what they weren't doing that actually was eye-opening for me. What I found in some of these visits is I found organizations that were building their first-generation data warehouses, but they actually didn't really understand at the time how to optimize database hardware for data warehouse, and specifically features that were in SQL Server at the time to support data warehousing. So it was interesting that they were not necessarily using the best software components or the best hardware components to solve their problems. And I realized we are throwing so much new stuff at our audience that we really need to think about a different way to package that. And if we, in my mind at least, if we were to deliver something, in the case of a data warehouse, that supported both the hardware and software around data warehousing, that would make sense. And we've evolved to where we're able to do that. So for me, appliances are really around delivering building blocks for your organizations that you can build complex solutions out of that start at a little higher energy level. Rather than giving you raw hardware components and DVDs with software that you can install, delivering a building block that's at a higher value. And different organizations are kind of in different places in terms of their ability to accept, maybe is a term, or utilize these kinds of solutions. One of the things I want to do is spend a little time explaining how to think about, or how we think about appliances. And we have a specific development process that we use. We'll come back at the end of the talk and kind of make a exclamation point about why this is important. But our process, you might think that we'd meet with our hardware partners and say, oh, there's some cool piece of hardware, let's build something out of it. We actually take the opposite approach. What we try to do is start out by understanding in a deep way the workload itself. In the case of our database consolidation private cloud, we looked at how our customers were using databases at scale. We went off and did research and collected information about lots of instances of SQL Server to see what the average sizes are, what the utilization was, how much I/O was needed, how much disk space. So we had a good data set for that. From that, we were able to create a model and then eventually a benchmark that would let us simulate at scale a typical environment in a data center with lots of SQL Server. And what we were being asked was, how do I manage that sort of infrastructure at scale? So from an appliance perspective, understanding that workload in a deep way, having an executable model is the key starting point. From there, we can look at the next step, which is the architecture. How do we solve that problem? There's different approaches. We could add features to SQL Server, let's say, that would add another naming level, that would let it be easier to mix applications together within the same database instance. We looked at stacking instances on the same server. And we looked at virtualization technology. Now, surprising to me, virtualization technology had moved a long way since the experiments that I personally ran. And our performance team reported back out that the OS and hardware guys had sufficiently optimized the solution end-to-end to where we're now at an overhead of somewhere around single digits, 2% I think is what we reported in that paper that we published, so that virtualization for databases is now a viable approach for scale-out deployment. Now, there's two main reasons. I mean, this information was counter to me when I heard it, and counter to my own personal experience, so I was pretty skeptical. But there's two developments that have occurred in this space that are critical to establishing this. The first is the implementation in hardware of address translation. If you're familiar with virtualization, one of the costs of that is you've got to translate from the memory inside a virtual machine into a physical machine. But what's happened now in the most modern processors is they've implemented that in hardware, so-called SLAT hardware, or second-level address translation hardware. And that solves the problem of, rather than having to have an expensive injection of instructions to do the math around computing the offset into physical memory of the hardware, instead that's now done actually in the chips, in the silicon itself. So huge progress in that space over the last few years, and now it's something that we can count on. It no longer is expensive to translate a virtual machine address into a physical address. It's done in hardware. The next is more important from a database perspective, is the fact that we've implemented the I/O stack, virtualized that all the way end to end. And the key essential accomplishment was eliminating the copy operation that used to be required when we did I/O in a virtual sense. It used to be, when we did an I/O, you'd have your virtual machine, you do an I/O into a virtual device, then you'd have to copy that virtual device into a physical device, and then you'd actually do the I/O for real. And so the locking and copying operation injected a tremendous overhead in the system to manage each individual I/O. That's largely been eliminated now, so that when we copy the data into the virtual device, we actually map that onto the physical device so it's done one time. And so there's no longer an additional copy operation that the system has to absorb as part of that. So from that, we were able to publish an architecture and recommend, going forward, we really believe that using virtualization is the right way to be able to scale out deployments of SQL Server with a common infrastructure. And that leads to some fascinating developments. From there, we went and were able to choose the software and hardware components to build out what we have as our appliance, and you can come see that on the show floor. So our approach, start with a workload, understand the various architectural approaches, and pick one based on its merits, and then choose the software and hardware components. So our hardware piece is last, not first, in terms of how we're designing these appliances. There is a family of appliances that we have here. I'll talk about these really quickly, and then we'll move on to the rest of the details. As I mentioned, 4.5 years ago, we were looking at data warehousing, and in fact, the data warehousing space has largely evolved to where many data warehouse products are available in appliance form, and that's something that marketplace has matured around that concept. We have two particular offerings that are appliances. And one's our parallel data warehouse appliance, and that's for very large scale-out data warehouses that use what we call massive parallel processing, or MPP technology. Our parallel data warehouse product allows you to maximize the use of substantial storage assets and use that to answer questions or answer queries associated with a data warehouse as rapidly as possible. And so that appliance is targeting the hundreds to greater and greater, hundreds of terabytes and greater type data warehouses. We also, at the other end, have a small data warehouse we call our starter data warehouse, or what our friends at HP call business data warehouse, which is targeted at the small end, little 5 terabyte type systems. And that's designed to be used for building small data marts. Now, in the BI space, we have an appliance that is designed for delivering the whole Power Pivot experience. If you're familiar with Power Pivot workload, that's something that we have an appliance for. Those small appliances are available less than an hour to put them in production. So really fast time to solution. The appliance we want to talk about here today is our private cloud appliance, or database consolidation appliance. And that uses what we call the Microsoft Private Cloud Fast Track Reference Architecture, and delivers that, using that as the basis for that appliance. So with that, I'll turn the mic over to Mark.
Great.
And you'll drive next.
Great. So when we talk about hybrid IT, we're talking about the merger between public cloud and private cloud infrastructures. And Steve will talk about how that works. And we also see some advantage to customers continuing to retain some instances that are traditionally hosted on bare metal, for especially those very largest and most demanding implementations. But for the private cloud, our benefits include the ability to have a pooled resource with elastic capabilities, so the ability to both grow the infrastructure as well as grow any individual guest within the infrastructure. The concepts of self-service, so that new instances can be provisioned on behalf of business users at their own behest. Of course, there would need to be some workflow-enabled capabilities in there so that you can institute appropriate operational control over the provisioning of those new instances and oversight to make sure that your customers are getting what they really need. But that concept of a workflow-enabled self-service portal is really key to private cloud and also key to our appliance infrastructure. And then usage-based metering that allows you to distribute costs of this infrastructure equitably between internal users of the private cloud. So a faster time to solution is something that Britt talked about in regards to our other appliances, but let me give you a specific example. So this morning, we started at the Server Aquarium at around 7 a.m. When we started, we got the email from our team in Northern Europe saying that the appliance that they stood up with the customer there was up and running, functional. They were sending us screenshots, JPEG from their phones of the full infrastructure up and running on site with the customer. So it was a one-day deployment effort over there. They'll spend the remainder of this week working with the customer on training them to do things like how to do physical to virtual migrations into the appliance, how to provision new instances from templates in the appliance, how to customize those templates, how to customize and tune their chargeback infrastructure to be able to equitably distribute costs to internal users, and how to customize the workflow for self-service provisioning so that that capability is up and running on the appliance. And they'll have those capabilities up and running for the customer and have the customer trained on how to run those capabilities by Friday. So if you compare and contrast that with the typical time that a customer would take to even just do the hardware evaluation of how to create a tuned and balanced infrastructure, you can see that appliances give a significant springboard to implementing your private cloud. So a self-build solution, again, can take customers typically months. And what we've done is acted as a springboard for that by providing you with a turnkey solution that you can put into production today. We had several tooling requests from customers as we were developing the appliance solution, where customers, you, told us what you needed to be successful. And so one of those tools was, you asked us for, I need a tool that can rapidly and efficiently collect an inventory of the systems running in my environment today. And once I have that inventory, I need to be able to select within that the instances that I want to evaluate for consolidation or implementation in a private cloud. So the MAP, or Microsoft Assessment and Planning Toolkit, is the foundation that we reinforced to deliver this capability to our appliance customers. And we further enhanced the MAP toolkit to actually provide specific sizing guidance for appliance customers. So let's say that your system is running on a legacy standalone server platform today, and you want to bring it into the appliance. The Microsoft Assessment and Planning Toolkit will actually map the compute memory disk footprint into the appliance and tell you what size of implementation you're going to need on the appliance to host that instance with no degradation in performance or response times. So what we want to do is make sure that as we're pulling instances into the appliance, that your business users don't contact you with complaints about a degradation in performance. We want to make sure that's sustained or enhanced. We also want to give you guidance to say this is how you should stack instances into the appliance to get the maximum density, so that you get a good balance of CPU, of memory, of disk, and of I/O capacity, so that those instances will cohabitate together and you get the maximum density in your environment. We've designed these heuristics and guidelines in a very conservative way to make sure that you do not adversely impact performance as you're bringing instances into the appliance. And we expect that customers over time will monitor those instances and perhaps even drive towards greater density once the understanding of those instances in their environment are better understood. So to introduce, we have Leisha He here in the audience. Can you raise your hand, Leisha? Just let people know who you are. Leisha is the Senior Development Lead for the Microsoft Assessment and Planning Toolkit. She has implemented all of the capabilities that are enhanced specific to the appliance, and she's available here this week. She'll be available at the Server Aquarium to answer your questions. So please, if you have questions, please ask one of us or ask the expert herself, Leisha He. So the concept, again, for the Assessment and Planning Toolkit is to discovery and inventory, gather your performance characteristics, define specific placement guidance for you, and then iterate that over time. So this is factory-optimized software. We built out what started with a reference architecture, and then we've enhanced that significantly around Windows, Active Directory, clustering, the Hyper-V configuration, the System Center infrastructure, and the SQL Server consolidation guidelines. It's a factory-built operation. So we have Joe Sullivan in the audience. Joe, can you raise your hand? So Joe is the architect and development lead from the HP team and has written literally thousands of lines of code to be able to develop this turnkey solution in the factory. As it leaves the factory, it's fully racked, fully cabled, loaded with software, and prepared to be deployed on-premise with the customer with the minimum of configuration input at the time of delivery. So springboarding a turnkey solution that we can bring into operation in about a day.
In the server, there we go. I'll start again. One of the benefits we got from the hardware design we had was that we actually end up with a very, very elegant hardware design. This is a picture of the back of the bottom of the rack, which if you go and have a look at it in the Server Aquarium, you know, most of you guys that walk around a data center will look at that and go, well, where are all the cables? Right? Because, you know, normally a rack that's got the kind of capabilities that we have in the database consolidation appliance, you'd expect to have hundreds of cables, network cables, fiber channel cables, all kind of cables just in the back of the rack. But using the HP Blade architecture and the converged infrastructure, we eliminate all those cables. So we actually end up with a really very elegant design. You can see there some of the performance numbers we have, 60,000 IOs per second, and that's random IO as well. That's a phenomenally high amount of random IO capability. And we think we actually eliminated in excess of 100 cables from the back of the rack. So that helps from many aspects. There's so many engineering benefits to having that reduction in cabling.
Those of you interested in the small print, 60,000 IOs at a 60/40 read-write mix with 8K packets and 25 millisecond?
Less than 10 millisecond.
Less than 10 millisecond response times.
Okay, where are we going here? Oh, space, okay. So one of the other things we did in our engineering approach was we wanted to have a very scalable solution. We didn't want to, we wanted to have something that a small customer could purchase, and so we started off with a half rack configuration, and that will deal with, most of our customers we think will perhaps go for a half rack or a full rack configuration. And that can comfortably run in this very conservative placement model 100 to 200 of our SQL Server VMs. Now, when we talk about those SQL Server VMs, we categorize them into small, medium, and large. And that's a categorization that works in a lot of different ways. The small VM has one virtual processor, 2 gigs of RAM, and about 100 gigs of disk space. Medium has 2 virtual processors, 4 gig of RAM, and 200 gig of disk space. And the large has 4 virtual processors, 16 gig of RAM, and 400 gig of disk space. And that covers, we think, probably 80 to 90% of the workloads that a customer wants to consolidate. Then we can move up from there to our full rack, where we can run basically double that amount. And if you need more than that, you can go to a multi-rack configuration. We can actually support up to 10 racks in a single appliance. If you need more than 10 racks, we just start out with a second appliance, and you keep on going from there. You can fill out a complete data center with racks of this stuff if you really need to. And you can see there some of the benefits you get from this very high dense approach. 35% reduction in costs in your first year, 90% energy reduction, 95% cooling reduction, 89% reduction in floor space, and 75% reduction in administration cost. Right? These are going to these kind of consolidated approaches. This is the real, in many ways, one of the real benefits that customers are going to experience is this phenomenal cost reduction. There's actually some very interesting material that MSIT actually produced. I don't know if everybody's seen the MSIT case studies. There's a couple of very good white papers they've written about green IT. They actually paid for the cost of the hardware replacement in 1 year just from the cost savings in power and cooling alone. So, that's something to really think about. So, this is a little bit more information about the appliance configuration we have. We need to fill in the right-hand one. Oh, one too far. So you can see here the details of on the left side, the base configuration, the half-rack configuration with 4 servers. That's 4 blades in the blade enclosure. That has a capability of 8 CPUs. There's a terabyte of RAM in there. The storage for that configuration is 20 to 8 terabytes of raw capacity, and that delivers 30,000 IOPS, and that's 30,000 random IOs. They're 8K IOs because that's what SQL Server drives. My expectation is a lot of you guys are not really SQL Server folks, so you'll be driving other workloads which have much smaller packet sizes, and so you'll get much higher IO throughput than we're talking about here. And if you start running sequential I/O on this system, then you can expect to probably 3-4x those numbers for sequential I/O workloads. When we go up to the full rack configuration, which is what you can see in the server aquarium, we have 8 blades in there. That's 16 CPUs, 192 processor cores, 2 terabytes of RAM. That's a phenomenal amount of processing power and memory capacity. 57 terabytes of raw storage capacity, and across the 396 spindles we have in there, and again 60,000 random IOPS. Again, those are those 8K IOs that we think about in SQL Server. 70% read, 30% write mix again.
The integrated switches at the top of the enclosure, just to call your attention to that, isolate that network traffic from the rest of your network. So it really makes the management of these virtual machines within the infrastructure isolated within the box. And For connecting this into your network, you go out of the backplane of the server enclosure just as you attach all the rest of the servers in your infrastructure. So all we've done in the networking infrastructure in the appliance is buffer or isolate all of that very demanding network traffic from the rest of your infrastructure. Likewise, by including integral storage into the appliance, we've isolated those very demanding workloads from shared storage environments. And again, just isolating those instances out gives you phenomenal throughput within the appliance and still gives you all the capability to integrate that to your existing infrastructure. The database workload provisioning scenarios, I mentioned these a little bit earlier, but just to highlight them once again, we have two primary scenarios for getting instances into the appliance. The first is taking physical instances and doing a physical to virtual migration into the appliance, and that preserves all of the associations that that physical instance had as it moves into the appliance. So the associations that those instances had to backup software, group policies, antivirus policies, various other security policies in your infrastructure are all maintained with no change at all required. And then in the provisioning of new instances, you're able to actually decorate your templates in a way that allows them to be provisioned with full capacity. And those can be provisioned either directly from the SCVMM interface as an administrator, or your end users can approach this from the self-service portal and request that instances be provisioned on their behalf, and that can be guided through the workflow-enabled process. So whether you're bringing in existing physical instances or whether you're provisioning new instances, those instances are fully capable inside the appliance as soon as they're brought in.
Do you want to start this? Okay. So I mentioned earlier on our small, medium, and large workloads. This is just some interesting information as to how the database consolidation appliance relates to some of the other products out there in the market today. The database consolidation appliance is the line along the bottom there. We've spoken a couple of times about the available IOPS. You can see what you see there on that bottom line in terms of the numbers of large, medium, small, and extra small. Those are ratios that we think is an average customer mix. It's what we call our balanced mix. In the work we did, we went out and spoke with a lot of customers. We got their map databases back, and we looked at exactly how many different sized databases they had across their enterprise. And this was the average mix that we found across a lot of those customers. And so you'll see this kind of come through in a lot of different places. And then in the lines above the database consolidation appliance, you can see how we compare to a number of different products that are out there today. The interesting column to really look at is the one on the right-hand side. Right? That is how many racks of that particular solution you would need to match the capabilities of the database consolidation appliance. It starts to give you some concept of just exactly how dense the database consolidation is in terms of compute power, memory, and storage capacity. And so the previous slide was looking at on-premise, private cloud competition. This slide is looking at more on the public cloud side of things. So we're looking at public IaaS competitors today. The first column there is our database consolidation. That's our extra large virtual machine. So that, you saw on the previous slide, we can run 16 of those in our balanced mix on one appliance. And if we only run those on the appliance, we can run, I think it's about 48 of those on a single appliance. Then in the next column, you see the Azure IaaS extra large VM. And you can compare some of the capabilities there. And immediately you can see that the database consolidation appliance exceeds by a considerable margin almost every single metric there. On the right-hand side, you have the Amazon Web Service XL VM. And again, that's database consolidation exceeds every single one of those metrics by a comfortable margin.
So when we look at performance and scalability again, we're looking at a system that's designed with significant density. It's tuned for demanding workloads. So while databases represent an example of a demanding workload, our customers are looking at many other workloads that will run well on a container designed for this kind of capacity. Also, the appliance is designed from top to bottom, side to side, with resiliency in mind. So we have redundancy at every hardware layer in the appliance, and we also have redundancy at every software layer in the appliance. And we've implemented as well DR capabilities in the appliance that enable customers to fail over even those applications that require multi-site resiliency. The unique appliance features include load balancing based on I/O throughput. So we have actually enhanced the management stack inside the appliance to be able to monitor the allocation or the consumption of I/Os per second by every VM in the appliance infrastructure. And if a VM exceeds its allocated I/Os per second, we actually fire a pro tip notifying the operations team to take action with the customer to either identify or resolve the issue through perhaps greater efficiency of the instance or through injection of additional resources if the capacity is required. We've built optimized tools for the private cloud, including the discovery and inventory tools that we mentioned earlier. We also implemented single point of support. How many of you have implemented multi-vendor solutions and then found yourself in a less than favorable position trying to resolve issues? Yeah? A few of you willing to admit it? Okay, so our support team in the back, we have several of our premier engineers. Can you guys raise up hands? They're also going to be at the Server Aquarium this week. Nick, Abhishek, and Jonathan are premier engineers that were handpicked to support the appliance as our mission-critical support team for appliance customers. They are a single call of support. They are the voices you will hear when you dial the call to Microsoft, and whether your issue is related to the hardware or the software, that team will help you through to resolution of your issue. Their skill base and the effort that they've put in over the last couple years, literally, to create the plumbing and infrastructure between Microsoft and HP to make this process extraordinarily efficient for you, is really a testament to their seniority on the team. So thank you guys for showing up. So please come and ask them in the Server Aquarium about how they're going to help you.
Okay, so what we've been talking about up to now is really about the appliance that's actually in market today. You can actually go out and buy a HP database consolidation appliance right now. It's running running Windows Server 2008 R2, and it's running the System Center old, we like to refer to 2007, 2008, 2010 products. What we're working on and what we're actually showing you in the Server Aquarium this week is actually an engineering prototype of the next version that's going to be available. Everybody is here to hear about System Center 2012, and that's what we're building into that appliance. As it says at the top of the slide, we're expecting that to be available in the second half of this year. It is a full implementation of the Microsoft Private Cloud Fast Track Reference Architecture, version 2. And that does move the whole of the management stack onto System Center 2012. So we're completely compliant with that reference architecture. We have a complete integration of all of the System Center 2012 products. So we have this great hybrid IT story where we have an integration of public and private cloud. We continue to have all that appliance added value from the unified health model that Mark was talking about. We're enhancing the version we have in the first model, which is mostly based around host health. So we have a unified host health model. We have a unified guest health model. And when we get to the demos, I can show you some of what that actually looks like in Operations Manager. We'll also have the pro tips for the guest workload monitoring. Mark touched on some of those earlier on. One of the things we've done is we wrote a bunch of custom management packs. We think we actually produced one of the first management packs ever that actually monitors storage utilization and can provide you with accurate pro tips for movement, quick storage migration movement of virtual machines when storage is getting hot. So that's a real benefit that you get with the appliance. Obviously, with System Center 2012, there's a bunch of new optimization capabilities in there, dynamic optimization, power optimization. We'll be looking to leverage those capabilities as well, again with custom management packs and custom configuration of the System Center stack as it's installed in the appliance. We're also working with the Cloud Service Provider Pack to utilize the self-service portal capabilities that gives for self-service provisioning and metering. And we're expecting to add on top of the standard reporting capabilities that provides you with to provide a more comprehensive chargeback reporting model. We've also been working with Leisha's team, and her team have been developing some improvements for us for the next version of the map tool. That will include primarily support for the next generation of HP blades, the Generation 8 blades, and also possibly a tunable placement model. Mark touched upon this earlier on when he was talking about map, and said we use a very conservative placement algorithm because what we want to do is we want you to consolidate into the appliance and be very successful from day one. We don't want you to be putting stuff in there and be fighting performance issues from the beginning. So our initial recommendations of how much stuff you put in here are very conservative. One of the other issues a lot of customers have is they don't have good monitoring of their workloads in their physical servers. Even customers that are running comprehensive operations manager and other System Center monitoring tools, they don't often have a consolidated view of all that performance data. So it's hard for them to know what a particular server's workload really looks like. However, once you've consolidated into the database consolidation appliance and are using the configured operations manager within the appliance, you will have a very good history of the performance profile of that application. Once you start to get that much more detailed performance profile, it's much easier to then determine how you can more aggressively place these things, how you can start to oversubscribe, and how you can start to put a little bit of more aggression into your placement model. The last point on here is the hardware refresh we're looking at, and one of the next slides will go into a little bit more detail on that. So, System Center 2012 in the appliance. A lot of the messaging is really about private cloud. We're using Virtual Machine Manager for our VM management. We have the self-service capabilities of App Controller and Service Manager 2012 with the service, the Cloud Service Provider Pack. And then we also have, we get the benefit of all the work the System Center team have done around hybrid IT. So we also get the benefit of this great private public cloud integration through Operations Manager and App Controller. One of the demos we'll look at what that actually starts to look like in Operations Manager, in seeing workloads actually running in Azure, being able to monitor them in Operations Manager in the appliance. We get improved orchestration through the work that the System Center have done with Orchestrator 2012, and obviously the service management work with Service Manager 2012, and then for patching and servicing, VMM 2012 really enhances our host patching story, and we get the benefits of Configuration Manager work and Orchestrator 2012 as well. And then again, backup and restore capabilities provided by Data Protection Manager 2012. And so now I'd mentioned earlier on a little bit about the hardware refresh. Coming along in the second half of this year, we're expecting to release versions of the appliance with the next generation of HP hardware, starting off with the HP ProLiant BL460C Generation 8 Blade update. That will have Intel processors, and so currently we have AMD processors. A lot of customers are either an AMD shop or an Intel shop. So we're going to enhance the capabilities and provide that Intel processor for them. And then in the Q4 of 2012, we'll be adding the Generation 8 AMD blade, the HP ProLiant BL465C Gen 8 blade. That adds the AMD processor update. And also in that Q4 update, there will be a hardware refresh for switches and Virtual Connect. Okay, so let's go and have a look at what that integrated health model looks like. Now, in here somewhere we should have... Oh, come on, off you go. That was the wrong one. There we go. And okay, so let's have a look at Operations Manager. So one of the other things we do is we have separate VMs for each one of the System Center products. One of the things that we're working on right now is exactly how we lay out the different System Center products into different virtual machines. What we've done in our engineering unit right now is we've actually been using the unified installer to actually install System Center for us. So one of the other things we do, though, is we have what we call a control node, so that your data center staff don't have to have separate connections open to Operations Manager and another desktop connection open to VMM and another one to Service Manager and another one to Orchestrator. We installed all the consoles into the control node. That's what I'm actually connected to now. You can actually, if you look at the taskbar at the bottom here, you can see I've actually got Operations Manager here. We have Virtual Machine Manager, and I've actually got Service Manager, and I've actually got a window open to App Controller as well. So the control node concept is basically that's the desktop that your data center staff connect to do any interaction they need to do with the appliance. Okay, so we're looking for what we want to look at here is the integrated health model we have. So let's close some of these guys up a little bit. And so here we have our standard Operations Manager view of the world. If we move down here a little bit, we will see SQL Server Appliances. So this will be something that you won't have seen before. One of the things we've done is we've actually created what we call our base management pack. This is a management pack that you can download excuse me, from the management pack download site, which understands all of our appliances. Now, it just provides basic discovery for the appliance and starts to light up the fact that you have appliances in your data center within Operations Manager. Now, on top of that base management pack, we then have appliance-specific management packs. And so underneath SQL Server Appliances, you'll see a database consolidation appliance. And this is our database consolidation appliance specific management pack. And underneath here, I'm going to come back to the dashboard in a minute, but we have the appliance. Now, if you have more than one database consolidation appliances in your data center, you will see multiple entries here. But this is one of the things, this is a unified health model for every single piece of hardware and software in that rack. We think this is something that very unique that very few people have actually seen before. You can actually get a complete health roll-up for every single part of the appliance into a single point. Now, as you can see, there's some warnings going on there. This is an engineering unit. Our senior developer, Tyson, is actually in the back office writing code right now, changing stuff, and so there's alerts firing off all over the place. The next thing I wanted to show you here was the appliance utilization dashboard. So this is a System Center 2012 dashboard that shows you the overall appliance utilization. So that is the utilization of all of the 8 servers and all 396 disk drives across the appliance. And we can see a little bit of a peak coming up here in the I/O. Tyson is actually doing some workload testing, and he's just fired up a bunch of workloads. We have 200 virtual machines running on 4 of those blades, and we're driving about, it looks like we're driving about 65% I/O capacity, right? This, again, is something very unique to the appliance that we don't think people would have seen before, this unified view of the overall utilization of a bunch of what previously have been disparate pieces of hardware. So this is another great benefit you get from the appliance approach. So this is kind of our unified health model, but this is really what we're looking at here in the health model. This is primarily the host health. So you get this today in the product we ship right now. What we're looking to add in the System Center 2012 version is guest health as well. One of the pieces of feedback we got from a lot of customers who were talking to us about buying the first version of the appliance is they were saying to this host health model, that's really good, but you're telling me I can run a couple of hundred VMs or maybe even a couple of thousand virtual machines. I really want to see the health of those rolled up into one place. I want to know is the whole of the appliance healthy, not just the hosts, but all the guests as well. So what we're going to be adding on is a DBC guest monitoring. Right? Now this is work that's actually in progress, so it's not where it should be underneath the consolidation appliance, but this is the kind of thing that we'll actually see, is we'll be able to see overall utilization and performance of all of the guests within the appliance. We will be able to see the health for all of the SQL databases within the appliance. We will be able to see the health of each of the database engines within the appliance. Now, obviously, this is very focused on SQL Server workloads. That's our primary focus. One of the other things we're looking to do is add into this model just Windows health as well. So, you know, we will have a general roll-up of the Windows health and the SQL Server health. Now, going on and looking at some of the hybrid IT elements of this, you'll see here we have a hybrid view, right? So what is this showing us? Well, on the left-hand side, we're actually looking at our SQL Server databases that are running on the appliance. And on the right-hand side, we're looking at some databases running in SQL Azure. So this is hybrid IT at work. This is a dashboard that we've put together that actually shows us both elements of this being monitored in the same place. And again, you know, while a lot of people talk about hybrid IT, we think there's very few places that it's actually being pulled together in this way. I think that's most of what we wanted to look at there. So let's go, okay, let's actually go down and app controller. So let's have a quick, you know, how many of you are already looking at private clouds and implementing private clouds? You know, is this a very new concept to everybody that's here? Is this something that you're going to be doing today? Any general? Yeah? So there's a bunch of hands, right? So what we're looking at here, this isn't really very specific to database consolidation, but it helps really get the idea across to people about how you can use the capabilities of System Center 2012 App Controller to do self-service provisioning. What we have is, so the fabric we have is the database consolidation appliance. That is a single fabric with 8 host servers built within it. What we've done within that, we've split that out into a number of different clouds. So what we see in the first one there is the DBC cloud. That is where our 200 workload virtual machines are actually running. And so we've broken that out into a set of resources carved out of the fabric that allow us to actually contain the execution and monitoring of those virtual machines to within a separate private cloud. Then we have a demo VM that I threw together to illustrate some additional capabilities if we want to dig into that any deeper. And then we have the management cloud, which is basically where all of the management virtual machines within the appliance live. So if we actually drill into that guy there, it's not going to show us. I need to go in the other way and look at it. But this is the private cloud approach. Now, this is looking at App Controller through the overall administrator of the appliance. If you came in as a user within the DBC cloud, all you're going to see is the capabilities and resources within the DBC cloud. All you can do is provision resources within the DBC cloud. So this is where it's useful to actually go back into VMM to see what's actually running in those clouds. So we can see in here in the DBC cloud, you can see at the top here we have 198 VMs in here. These are all of our workloads that are actually busy running away. You can see on the right-hand side here some of the CPU percentages that are actually running across those machines. These are the ones that Tyson's hammering away on right now that we can actually see the performance counters running for. And then in the demo cloud, this is where... where's my scroll bar? It's gone. I've lost some VMs. Okay, that bit of the demo is not working very well. Let's move on to the next part. Here we go. And so now here we can see the management virtual machines. And you can see we've actually got 16 virtual machines. So in the current designs we actually have about 24 different virtual machines running in the management stack. In the implementation we have right now, we've reduced that number slightly, and we have just 16. As you can see, we have a specific naming convention we use to place each of the things. And this is part of what happens when you buy an appliance. It has this very specific configuration which we have laid down as part of our best practices, which is driven by that Microsoft Private Cloud Fast Track Reference Architecture. You get the benefit of the expertise of the engineers behind the Private Cloud Fast Track Reference Architecture. You get the benefit of the engineers in the appliance engineering team. You get the benefit of the engineers at HP, all coming together to provide you with a really a complete configured solution. Let's go back. What happened to the... Okay, so we also looked at hybrid IT. So the other aspect of the hybrid IT is actually managing the cloud from App Controller. We weren't actually able to configure our Windows Azure subscription in App Controller, so I can't actually show you that part. But that is, is that something that a lot of people have a great deal of interest in actually managing? Let's turn that around again. Let's ask the question a bit more specifically. Who is actually looking to use Operations Manager or App Controller to actually manage or monitor across public and private clouds? Okay, so there's a good handful of hands, right? So have you all been to the App Controller talks and the Operations Manager talks already, so you're aware of these capabilities? Or is what I'm showing you here kind of new to you folks? It's okay. Okay, that's good. Okay. So one of the challenges we have is we're the SQL guys, right? And you guys are the System Center guys. So I was expecting to come in here and be showing you Operations Manager. You go, yeah, I know all about that. And I've seen App Controller before. So it's kind of nice to see that we're actually able to show you some new stuff as well. And I think that's about it, actually. I don't know if we have any questions. But we're into that session now. So, yeah, question down there. Gentleman at the microphone. Yeah.
Is this on? Mm-hmm. Yeah, the question is, if we have multiple cabinets in this situation, it sounds like each one of them would be a different SCOM implementation, right? It's a different management group.
Yes.
In an organization, a big organization that already has SCOM, it seems a little extra, like a lot of extra work to have all these extra SCOM implementations. Would we have to use that in each of these cabinets, or would it be a violation of your support?
So what actually happens is when you buy an appliance can scale up to 10 racks. All of those 10 racks are managed by one set of System Center infrastructure, right? So there's one SCOM in the first rack. There's one VMM in the first rack. Now, if you already have SCOM and VMM in your environment, that is a little bit of duplication. We do expect you to manage the contents of the appliance with the SCOM and the VMM that's in the appliance. We do, however, provide guidance for how you should integrate our SCOM with your existing SCOM. That guidance is currently based around the old version of SCOM, and as we release this new version of the appliance with System Center 2012, which does change the whole hierarchical model of the old version of Operations Manager to the new peer-to-peer model with 2012, we're going to have to update that guidance. But yes, that is an issue. What you don't have, though, is you don't have Operations Manager per rack. It's just once per appliance, and you can have 10 racks of that before you need a separate second instance of Operations Manager. I think we have a... Oh, sorry.
I may be able to infer the answer to this question based on what you just said, but one of the considerations that I'd be thinking about is if we've already done our licensing with Microsoft for System Center 2012, and we hadn't considered taking in the appliance, how is that going to help, or how is that going to, am I getting any credit toward licensing I've already made? Is it licensing through HP? How is that going to work?
So I think there's two parts to your question. The first part I think we kind of answered in how you have to have Operations Manager in the appliance running. In terms of the licensing question, that is a very interesting question. You do have to license the software in the database consolidation appliance. There is a separate SKU for all the software in the database consolidation appliance. It does start to get interesting though, because, and Mark, do you want to take this? Because of the way that the licensing is negotiated. I'm the engineering guy.
I like how you punt it right back.
Yeah. So the key is on licensing. We want you to be able to leverage the licensing that you have, especially in the guest environment. The appliance itself has its own integrated management infrastructure, and that license we've also addressed as a SKU. So appliance customers who are buying the appliance today get the full System Center suite, and they get the full upgrade rights to the 2012 suite.
Okay. In the fast track reference architecture that you mentioned, Microsoft currently has a number of white papers on, I believe, which were dated in 2011, which was the original. Is version 2 that you're referring to available publicly for review?
I think that's actually being launched here.
Yeah, I think you'll be hearing about that this week.
We might not have actually been supposed to mention that today, because it might be, I think it's being launched on Tuesday or Wednesday. So.
Okay, great. Thank you.
Okay. Yeah. So the question over here.
Top secret.
So is this appliance, I've seen a demonstration on your BI appliance where it's a different version of SQL, basically a hybrid version, specialized for BI workload. Basically, this is still just plain regular SQL Server 2012. There's no difference in that product and what you run here in this appliance.
So the private cloud appliance is a little bit of a different breed because it's so much of it's a much larger solution, and upgrade paths have to be, incorporated into the design. So in that way, we are aggressively working on the 2012 upgrade to the appliance infrastructure. So does that address your question?
Well, my question is, are you running SQL Server 2012, the basic raw RTM version, or is it a specialized version?
Oh, very good. Okay, so in the appliance, the container management infrastructure, we're using the current version of SQL in there because that's the version that's currently supported. In terms of what runs in the guests in the appliance, it was actually a ship criteria for SQL 2012 to run well in the appliance. So we have SQL 2012 running in the guests today. And it's running great. And all the always-on capabilities are implemented. Everything is supported.
You can run a little expansion on that. So you can run any version of SQL Server in this appliance.
In the guests.
Including 2000. So anything you've got out there will run.
So it's not a specialized version of SQL
It's not.
Server?
It's completely. It's all the currently shipping versions can run in there at the same time.
And is there any feature benefit in terms of if you need to upgrade SQL Server versions or OS patching? Is there any features that you can benefit from this infrastructure?
Yeah, we're seeing that a lot with customers. So one of the key scenarios that customers are approaching us on is, hey, I've got a lot of instances that I need to get off SQL 2000. So what's the approach for getting them migrated into the private cloud, and will that help me with my upgrade process? And the answer is yes. Best practices we're recommending there would be to take your physical instance today, bring it into the appliance, then once it's in the infrastructure, provision a new instance using your templates, and that would then be exactly to your corporate standard, and then do the data migration within the appliance from the old instance to the new instance and flip over your middleware and tier 2 and 3 application components to point to the new DB backend. So that kind of approach is being used a lot by customers today as a migration exercise.
The amount of polishing that you can do in terms of consolidation and getting consistency across all your workloads, that's completely up to you to determine how much you want to do. If you want to take the raw servers that are in the wild and bring them in on board and stop there, you can. And for some, that might make sense because maybe you're going to replace those with the new implementation of something near term. But for others where you want to invest in that, you can. The appliance is a good place to do there. What I like to say is there's a lot of air to breathe. There's a lot of memory, a lot of processor, a lot of storage there. So doing those kind of migrations and upgrades is easier in the appliance, generally speaking, than on the metal or where the systems exist today.
I think we have another gentleman over here is next.
Thank you. Could you discuss for us how we could use this particular strategy to help mitigate the recent licensing changes with SQL Server 2012?
Yeah, so the recent licensing change to SQL Server 2012 changes us from a per proc model to a per core model. But with the appliance infrastructure that we have today, another thing that was negotiated there was a 0.75 factor to your licensing count for the AMD processors. So, we've mitigated that change to a certain extent in the appliance. And in the next generations of the appliance, where we're incorporating the Intel blade sets, you can see some further enhancements in that.
There's a really important change from a licensing around how enterprise has evolved. In SQL Server 2012, the enterprise license has unlimited virtualization rights. So if you were, for example, running many servers on the metal with enterprise today, and you bring those into, if you will, the appliance, then the upgrade rights you're going to have are going to give you, they're going to unlock a lot of potential in there. Because all you license is the hardware. So the virtualization rights, if you will, the scale on the system, you'll be able to unlock that because of the unlimited virtualization rights. So while everybody's different in terms of their particular current licensing, what their migration or migration rights are for the individual licenses, it depends upon how you bought them and how you've maintained those over time. What we encourage you to do is have a conversation with your account team, and they can help you walk through that process. There is some guidance that they have around that. And there, as we mentioned, the map tool can really help you understand how much will fit in that. So we do have customers that are in very different places on that. It goes from one extreme where customers have a bunch of really old licenses with no migration rights, and they haven't done any maintenance on those, and so they really don't have any rights to migrate those, and they have to work with their team to do that. To the other extreme, where people have existing active under SA kind of licenses, and they can literally bring those all in the appliance and they're done. So they don't have to purchase any additional database software to run, and they actually unlock unlimited virtualization rights as part of that migration. So it really is going to be specific to your situation how that's going to occur. One of the things that we've focused on, though, is making sure when we built the appliance, how you buy hardware, how you buy software does not change relative to your current process, your current discount structure and agreements that you've already set up don't change relative to this. You buy hardware and software the same way you have in the past. It's a different way to deploy it.
Another way to think about that is, while you might look at the 192 cores in a full rack of database consolidation appliance, multiply it up by the per core price of SQL Server and go, wow, that's an awful lot of money, okay? You can put 1,000 servers into that full rack, right? And those could be 1,000 2P servers, which are 3 to 5 years old. So if you do the math on that, it's really, really good value, even with the new licensing model.
Does that address your question?
I think it does. I mean, from a licensing perspective, I could see where Microsoft is going to drive the industry and drive its customers. I guess where my concern is, our experience has been when you get to a certain level of density on the servers, you run into practical problems. If you have 500 VMs on a box and you've got a terabyte worth of memory and you want to do a migration, migrating a terabyte of memory takes a really long time, even with really, really sexy gear. So you start running into things where the very most I'll have is maybe 100, or 75 or some number. Coordination of maintenance windows, coordination of all this other kind of stuff affects your ability to drive that ultra high density that you're talking about in this meeting. I don't dispute that you could technically pull it off, but from a day-to-day management perspective, it's very difficult to do in large enterprises.
That's one of the reasons we have guidance around, from the tools that we talked about, the map tool in particular. Not only do we provide guidance about what fits, but we provide guidance around what does not fit. And so if we find a system that, based on our measurements, does not fit within the appliance structure, we're going to tell you that, and we're going to tell you why we think that's the case. Often people can look at that and understand whether that's true or not. Sometimes we don't necessarily understand fully the environment, but we're biased towards not encouraging onboarding, if you will, of the wrong workloads. Usually people have enough workloads that if you focus on the ones that fit well, you can start with that, get that experience, and learn from that, and then understand as you get further out in your list the stuff that's a little more demanding and whether or not that's gonna work well. There are always going to be some servers that need to stay on the metal relative to that, at least in the near term. I would imagine another couple of years from now that guidance will change, but for today, there's a certain percentage that you're going to want to leave on the metal for at least another couple of years.
Yeah. And I mentioned earlier on about how we think about the workloads. Britt started off talking about the fact our whole engineering approach starts off with the workloads. This appliance is designed for small, medium, large. Large is a maximum of 16 gigabytes of RAM. And the example you quoted is a great one with a VM, a monster VM with a terabyte of RAM. If we were going to try and design an appliance for that kind of workload, we would design a different architecture that would actually provide capabilities for live migration of those massive amounts of memory. We've focused on those small, medium, and large workloads. So what we've designed works very, very well with those size workloads. We can actually know that we know we can live migrate within the appliance under full load in very, very quickly. I think there's another question over here.
My question's about availability. Do you use any of the turnkey solutions around SQL clustering to have local high availability?
So do you want me to take that?
Go ahead.
So the high availability.
We could spend, by the way, about 2 hours on that question. But,
Yeah.
That is a
we'll
really
do the
that is a
short
really
version.
good question.
Yeah. So for high availability, we've designed high availability into the hardware from the ground up. Right? There is no single point of failure at any point of the hardware within the appliance. We have duplication and, in some places, multiple levels of redundancy through every single part of the hardware design. And as Mark pointed out, it's not just the hardware, that's also in the software. So we have HAVMs where necessary. Hyper-V gives us the capability to have HAVMs in the guests as well. And we have the ability to build guest clusters if the customer wants to do that. The always-on technologies are really, you think about them as being running in the guest workloads. And we think about that as part of our DR solution. So for our DR solution, you would start off buying a second rack, put it in a separate data center somewhere else, and then you choose which workloads you want to incur the additional cost of setting up DR to that secondary site. We don't think that most customers don't need DR on everything they have. They need DR on a small set of the most business critical, mission critical stuff they have. There's a lot of stuff they have which is less critical that can afford to take an outage in the event of a disaster. So our DR solution is based upon DR at an individual workload level, and you can use any of the proven SQL Server technologies for disaster recovery, such as database mirroring, replication, log shipping, and of course with SQL Server 2012, the always-on technologies.
The always-on stuff works particularly well.
Yeah.
And I suppose you could use Azure as your secondary site as well?
Yeah.
So absolutely, that's something we're looking at, exactly how we can embrace that. That's going to be something we want to add on as capabilities for this next version of the appliance.
We're not quite ready to talk about that in detail, but pay attention to that area.
Yeah.
There'll be some new stuff coming there.
Smart
And I guess the strategy then for if I have high availability databases on a SQL cluster today, I should just concentrate on migrating the data to an instance that is housed on your server as opposed to trying to move
that's a really great topic to touch on quickly here. Traditionally, as practitioners building reliable systems, often we've relied on a failover cluster with fully redundant servers to support those, and so we end up having to have two physical systems sitting waiting for a failure. You can run them in an active mode by running half of the app on one and half of the app on the other, and then having failover for each other. So you don't have to sit completely idle. But that kind of a model where you're leaving at least 50% of the capacity of that total system unused. In the virtualized infrastructure, there is a new option available to us because we can do what we call a fast restart of a workload on a nearby cluster. You could think of it almost as a virtual failover cluster that doesn't actually exist, but you can think of it as existing. So what can happen is let's say we lose a blade or a server in our private cloud, the virtual machine manager will know what workloads were on that particular server and restart them on all the other servers using load balancing. So we will fast restart all those workloads on some other particular server. And so without having to have pre-configured, pre-allocated VMs or servers running for all of those workloads, we actually can do the same, or accomplish the same effect in nearly the same time in terms of outage that you would have for a traditional failover cluster. Because it takes a while to recognize that it's down and then recover it. And that's because in the private cloud, all of the resources have access to, at least the way we've built ours, all the resources have access to all the storage. And so we can restart those servers. It's a new level of HA, if you will. And generally what we find is most customers find that new level actually very useful. And in some cases, can dramatically reduce the total hardware investment, because you actually don't have to have half of your hardware sitting idle waiting for a failure to occur across all those different systems. You can essentially share that failure model, if you will, amortize that across your full private cloud. So one of the real benefits of pooling, we talked about those different attributes of private cloud. Pooling of our HA asset essentially is what occurs, and so there's a dramatic reduction in pre-allocated hardware for HA as a result of that. I'm glad you made that point, because I particularly find that to be fascinating, that here we are all the way through this amount of time. I've been doing databases for 30 years, and all of a sudden a new kind of HA pops up out of the blue, and I think that's pretty fascinating.
Thank you very much for coming today and spending time with us. I understand there's a lot of competition at MMS. We really appreciate that you've come and stayed with us through the day. We are going to be at the Servaquarium for the entire week.
Come visit us at the Servaquarium. We're happy to talk to you as long as you want.
Yeah, we're all going to be available all week long. We really hope that you'll come by. We have a lot of offers to help get you off the ground, help you run the map tool in your environment, understand the way that the appliance can work for you in your environment, and we'd be happy to help set that up with you. So please come by, let us know how we can help you, and we're all here all week. Thanks again.
Thank you.